Good day. So this one was sent in from a friend, and it was asking for to solve for these variables x, m, and p for the similar triangles. Okay, the problem said something about similar triangles. So I kind of pulled this up. This little test for similar triangles. Here's 3 tests that we could use to note if triangles are similar. And so what I did, I guess the first thing I did was to break these triangles apart. Okay, so here's the large one. Here's the smaller one. Okay, remember, these are the variables we're trying to solve for. So the first thing I did was separate these triangles into 2 of them, one large and one small. So we note that both of these triangles have 90-degree angles. And what I do is I just basically start filling in the sides with the variables that were given. Okay, here's the small triangle. Here's the large triangle. The bottom is 28. Now the hypotenuse for the large one is going to be m plus p. Same with the left-hand side is going to be 27 plus x. Okay, because of the sides here, m plus p for the large one, x plus 27. Okay, and we also note that these corners here are shared. Okay, both triangles share this corner. So now it passes the test for similar triangles. The 2 pair of corresponding angles are equal. Here's the first corresponding pair, here's the second. So now we know that this kind of opens up the ability that we could use these ratios. Okay, if the triangles are similar, that means that the ratio for the from one side to the other, okay, for example, the ratio of 28 over 27 plus x is going to equal the ratio of 11.2 divided by x. Okay, you can kind of think of ratios like this: large over small or large over small. So what I could do is I could say, 28 divided by 11.2. Okay, that's your large triangle over your small triangle. Okay, all I'm doing is I'm saying that the ratio 28 over 11.2, that's also going to equal 27 plus x divided by x, because these ratios have to be equal. Okay, that's what happens when you get similar triangles. The ratios are equal. Okay, I kind of want to note that for your ability to do these ratios, you have to unlock it with one of these 3 tests. Okay, it only works if the triangles are similar. Okay, for you to be able to use this technique, it has to pass one of these 3 tests first. Okay, so 28 over 11.2 equals 2.5. So we're going to say 2.5 equals 27 plus x over x. And now we're doing some basic algebra here. We're just going to multiply both sides by x. Okay, what that does is it gets rid of the x here in the denominator, doing our transpose and apply. So we have 2.5x equals 27 plus x. Okay, subtracting x from both sides, we get 1.5x equals 27. Okay, just doing your transpose and apply across an equal sign. So, subtracting x from both sides, 2.5x minus 1x, 2.5 minus 1 gives us 1.5x equals 27. Okay, so getting x by itself, 27, what we're going to do is we're going to say x equals 27 over 1.5. Okay, so 27 divided by 1.5, that gives us 18. Okay, so now we know that side x equals 18. Okay, so we also know This side is 27 plus 18. We have 27 plus x, so we're going to call that 27 plus 18. Okay, it gives us 45. So this side is now 45. Okay, what I suggest now is going after this variable m. And to do that, we're going to do Pythagoras theorem. Same with m plus p. So Pythagoras theorem is for right triangle, we know a squared plus b squared equals c squared, where c is the hypotenuse. Okay, remember Pythagoras theorem, a squared plus b squared equals c squared. C is the hypotenuse for right angle triangles only. Okay, so 11.2 squared gives us 125.44 plus 18 squared equals 324. I'm going to say that equals m squared. Okay, so now we have 449.44 equals m squared. Okay, so now what we have to do is take the square root of both sides. Okay, that's going to give us m. Square root cancels out a squared. Okay, square root of 449.44. It gives us 21.2. So now we know m is 21.2. Okay. 21.2. So now we know that the last variable we got to find is this variable p. Okay, so Pythagoras theorem, I'm going to say 45 squared plus 28 squared, that equals m plus p squared. Okay. Okay, so we get 2,809 equals m plus p squared. So to kind of get this apart, what we're going to do is take square root of both sides. So we get 53 equals m plus p. Okay, remember we already know what m is at this point. M equals 21.2. So we could kind of place that in here. We could say that 53 equals 21.2 plus p. And then subtracting 21.2 from both sides, we get 31.8 equals p. So we know now that p equals 31.8. Okay, there it is, the end of the problem. Those are the three variables you were looking for. So remember a couple things that when we were doing this, first we had to prove that they were similar triangles, and then that kind of opened up this ratio that we could use, large over small. Okay, not only is that ratio goes large over small, but that also means the ratio of the triangles is similar sides. So this side divided by this side, okay, is the same as this side divided by this side. Okay, that also goes between triangles. So this side divided by this side equals, this side divided by this side. Okay, it goes back and forth between triangles, these ratios. Okay, once they're similar, that means the ratios from one triangle to the next apply. Okay, also within the triangles themselves. So that's kind of how the ratios work. First we did the ratios, okay, solving for x, and then to solve for the other problems we used our Pythagoras theorem, the a squared plus b squared equals c squared. I hope you guys enjoy this video. It's a quick video on similar triangles. If you like these type of videos, please press the like button, leave a comment down below, and if you want to see more, simply subscribe to my channel for more videos. Thank you.